The next person that I'd like to introduce works for a great company, GitHub and Atlassian. I think are sort of, people always ask me how we get along with Atlassian, and they're the best. We actually did a karaoke contest not too long ago in San Francisco. Unfortunately, GitHub lost. It may have been because I was on the team. If you'd like to see a demonstration of those skills later on tonight, you probably couldn't stop me from doing it, so it may happen. So this guy's a developer advocate for Atlassian. I'd like to sorry, hold on, let me do this again. I'd like to introduce you to John Garcia.
Thank you. Hi, thanks for coming out today. I hope everyone's enjoying Paris. This is a beautiful city. Hopefully you have time to get around and see some of the great sights. I took in the Eiffel Tower when I first got here, and that was outstanding. But yeah, I'd like to begin first with introducing my talk. I'd like to talk about, as many people here have, the challenge of monorepos, or dealing with large objects in Git. This is a problem that many of us face. I'd like to introduce myself. I'm a developer philosopher, which means that I look at what the humanities and the arts have to say about development and try to synthesize that into a philosophy about how software can best be developed. I got my start at a very young age with this machine. If you don't recognize it, this is the TI-99-4A. This is one of the first machines that you could just throw on your living room floor and plug into a regular television and do whatever you wanted. I learned TI Basic with it. Fast forward 20 years, and now I'm working with Atlassian at Bitbucket, and we are a large DVCS provider. A lot of folks use us as the source of truth repo for their team. We have more than 2 million users, and so we hear a lot from the Git community at large about their experience with Git. We love Git. It cannot be emphasized how much we love Git, because for us, Git is sort of the rising tide that lifts all boats. We have a lot of products that work in sync with Git and enable teams, both large and small, to use Git to its best capabilities. So I'd like to talk about why we love Git, and that has a lot to do with the Git feature set. So it's important to look at data integrity as a large part of the feature set, because as each file is handled by Git, it's checksummed into a hash file, and that allows us to efficiently make good choices about how we store the file. It has an advanced branch model, which allows distributed work among teams who can then merge their work later without the necessity of scheduling work. And it has file splaying and chunking capabilities to enhance file system performance and to prevent overstoring too many files in the same folder. So getting a little bit more into depth about these topics, data integrity, when Git operates on a file, it'll make a checksum out of the file. And if it recognizes that this checksum is similar to a checksum of another file that it's storing, it'll know that it only has to store that file once. Another thing we love is the branch model. The branch model enables work to be done specifically on one branch and to be compartmentalized, and generally allows the end user to control the amount of data that they share with the server, thus restricting bandwidth use and making good choices with your resources. And then we can ignore other branches as needed. I'd also like to talk about file splaying. File splaying is the process of storing the files in the Git repo in folders that start with the prefix of the hash, so that we don't end up with a folder with 1 million files in it. We can have 256 folders, each with a subset of the repository. So as has been discussed many times on this stage today, there's a conflict that we keep running into where the artists and the scientists that work with Git have a need to store large files. And they have a really compelling need, because with the decrease in the cost of storage and the increase in the cost of computing power and the speed of transit, we're able to make much more compelling art and much more compelling virtual environments, and in some cases even solve the problems of humanity, such as curing cancer. So let's talk a little bit more about the object model and how this becomes a pain point. So we tell folks, don't store your large objects in Git. This is a kind of a proxy for a large artifact. This is a work of art that's been made by humans. It's huge, and it has no place in your Git repository. But sometimes that's exactly what you end up with. And so we looked at the folks that are reporting these issues to us and kind of took a look at the taxonomy of what the objects look like. So for us, generally our problems come with package repositories such as Bower or archives. Other use cases will have problems with either audio formats or video formats that take up a large amount of space. But then there's also scientific computing needs, such as MATLAB and Simulink and the large database like MongoDB setups that use huge amounts of structured data. So over time, I did some research in our support database, and over the course of 2 years on the calendar, we saw 5.2 issues per week related to large repositories. That's more than one every business day. Quite literally, every day, somebody is calling us to talk about their large repo. And they're sad. They're very sad. And they say things that make us sad sometimes, namely that they're going to leave Git. So let's talk a little bit more about the object model and perhaps what we could do to adjust. And this is very similar to what Rick was talking about and similar to what's been done in Git Media and other existing art. And what we do is we like to, if we can, store the text artifacts in the Git repository, but store the binary artifacts in a offsite storage solution such as S3 or possibly even on a local drive if that's appropriate. So we've been doing a lot of research and we've had a lot of thought about this problem. And I want to show you guys what we think about it and maybe a little bit of a proof of concept at the end. But I want to be really clear that we don't intend to prescribe where this conversation goes. We really just want to put the results of our research out for the community to see, to hopefully help the community find the best solution. Because it's really, and I think everyone here can agree, it's really best for the basic fundamental tools that we use to be tools that we can all use and we can all contribute to. So in our research, we identified a few potential areas of improvement. First of which is cross-platform support. We feel that any solution to the large binary problem should be platform agnostic to the degree that it's able to work with POSIX and non-POSIX systems, and also work with a variety of backends. Your S3, your local storage, if you want to use like a Fuse file system. We feel that that sort of interoperability is really crucial. Performance is another big question for us, another area of potential improvement. We find that the existing options, when they make serial operations on a large number of files, they can have significant overhead from starting the virtual machine every time they work. Finally, we think that a complete solution would probably address the question of file locking. And of course, that's a very difficult question. It's certainly a contentious topic in the Git community and really in distributed version control thinking at large, because that doesn't fit so well with the distributed model. So for performance, the issue that came up for us, or rather our observation, was that existing solutions use smudge and clean filters when they operate on files. And this is very much like what Rick was talking about a moment ago. And so you start with when you make a checkout, you download the repository. And if you're using an external storage solution, you'll generally have files that have references to the external objects that you need for your repository. And then on checkout, the program will transform that into the actual artifact. Then on commit, the opposite is done. The artifact is distilled into a checksum that's put into a text file. What can happen is that if you have a huge number of objects and you have to iterate over each of those objects in sequence, that's a lot of serial operations, and even the slightest overhead in starting your process will add up over time. So let's talk about portability as well. We feel that it's critical that a great solution will work with all types of computers, but it will also work with all types of backends. It'll work with cloud storage, local storage. Ideally, it would even work with Samba or any sort of storage that you have. And finally, we find that a package that's easy to distribute, much as what Rick said, that is able to compile a static binary that can be distributed instead of dealing with runtime dependencies or some sort of installer, makes a much more compelling case for uptake. It makes it a lot easier for people to package it, for users to download it and install it, and generally it's a much better experience all around. So, I want to talk about file locking, because sometimes you just can't merge, as we can see here. There are file types that, I mean, of course everything can be merged, but there are file types where the cost of merging, if human reviewers must review the code, the cost of merging is prohibitive. So it's important that we at least consider what we might do to help proactively prevent merge conflicts for certain file types. And so we've kind of looked at what kind of files that happens with, and it's the usual culprits, the large binaries such as your audio files and your video files, but in addition, some of the larger expressions of Markdown or XML, or even auto-generated files by Unity and SolidWorks can be very difficult to merge as well. So we've come up with an idea for branch-oriented file locking, which would provide a way for you to serialize the commits on a single file and still interoperate branch-wise, but not ever have a conflict. For starters, you download your repo, and when you make your clone, the file types that are controlled in this way would be locked for modification. And so because of the process that they've been going through, they have a serial commit graph, so that even though each commit may come from a different branch, each commit is an atomic expression of the new file. So if you need to check out this file, or you need to unlock the file, we would expect that you would download the newest copy of the file, and then when you do, we release the lock and allow you to make changes. Once you've made changes and you're ready to commit, you commit that to the newest position in the repo, and that becomes the new position of the file. Of course, any solution like that that's prescriptive should follow the regular Git rules, and the regular Git rules include a functional force option to allow users to make sensible decisions when there's unexpected circumstances. So, for instance, if somebody locks a file and then goes on vacation or leaves the organization, users need to be able to say, we understand that there is cost involved to allowing a concurrent modification. However, we're willing to bear that cost. So I want to talk a little bit more about expanding the object model as well. So we can see we have a large object in this repository. So what we would really like to see is a splaying happen, so that, as with regular Git, the large objects are stored in folders that are prefixes of their hash code, so that they're both easy to find, and also they don't accumulate too much in the same folder. And then from there, we can transport them to external storage. Another important part of the model that we consider is local object retention, which is to say that it's important to consider which files you would want and which files you would not want to keep, so that you don't fill your hard drive entirely with files. This is really a local process that I'm going to describe, although it seems like the brave at heart may apply something to the server end as well. So we kind of break up the commit history into 3 distinct bands. a near-term band, a mid-term band, and a long-term band. So in the near-term band, we expect that your current checkout, which is represented here with the blue branch, you want those files. In addition, this green branch, which shares an ancestor with that other branch, we want to keep those files that are less than 30 days old as well. In addition, in the mid-term band, we want to make sure that we keep the files on the branch that we're using, but files that belong to a different branch we may not be concerned with. We think that you won't. And files beyond 90 days, we're pretty sure nobody is concerned with. So this kind of provides a paradigm for garbage collection or reclaiming local storage. We're reluctant to say garbage collection because that is a specific thing that Git does. And it's very important, as Rick mentioned, to maintain consistency with the Git model and the Git behavior pattern so that it's less learning curve for any potential users. So I'd like to show you a proof of concept that we've been kind of working on in our lab and give you an idea of what our thinking is on the subject. So here I am creating the large object store on my Raspberry Pi using SSHFS, which is a Fuse implementation, creating the repository in Bitbucket, initting the repository on my local machine, and then adding and committing my first files. I used my Raspberry Pi to point out that this works really elegantly with any sort of back-end storage. A core design feature is we want it to be not locked into anything, any sort of service, any sort of server. We want to keep it as simple as possible. So here I'm adding the parameters to my .git/config, and I'm going to do my initial push of large objects. This will take a while, but I fast-forwarded it for your viewing pleasure. So we see there's 66 megabytes to upload, and that's now done. We can see there's now a file on the Pi. So we copy a new file into the project, commit that new file, and this uses the smudge filter to clean the file and change it into a actual repo item. And now when we push, we see that we're pushing up to 2 commits, but we started at 51% because we've already pushed the first file that belongs to this commit. Now we've pushed the binaries to the origin, and it's time for me to open the file and do some work. So here's a previous version of this presentation that we're watching right now. And it came to me that this would be a great slide for the demo rather than a quote. So I'm going to make a new branch for the video, store that, then also store the artifacts. And again, we'll see that when we do the push, we won't have to push the entire stack of large objects. We'll only push the one that is not known at the repo. I'll fast forward to that again. So now that that's pushed to the origin, I'm going to make a new clone of the repo so that I can kind of simulate what it would be like if my coworker Nicola were to work on this. So he pulls it up, he adds in his configuration, saves the modified files, pull the binaries, and of course this takes some time. He's got to download the entire set of binaries because he does not have access, or he does not have the objects that I've stored yet. But once he's downloaded those, he's ready to start working. So he'll open the file. Oh, wait, no, that's the wrong one. That's the wrong branch. Let's change branches. Notice changing branches took just a moment. So now we're on this new branch. We want to put a placeholder in for where the video scene will go. And then we'll save it. We'll commit this. And then we'll push the repo up to the origin and push the large objects up to its storage. And we'll notice again, this starts at 75% because 3 out of the 4 objects are already found at the storage location. All right, now that that's complete, I want to look at the large object store and see what's on my Pi. Oh, it looks like I have 4 folders now, 1 for each of the objects. Those files in the stores are chunked, which is to say that they're broken into smaller pieces so that if a part of the file doesn't actually make it, it can be uploaded separately and as just a chunk in the event that there's some sort of a connection interruption. So now I'm going back to my copy of the repo, and I've downloaded the new objects and the new commits. And you can see that my copy of the presentation now has a pane for the video. So I'd like to summarize. Thank you for your time today. We feel that there's definitely an opportunity for improvement that's been identified by all of the major vendors of Git hosting. And we feel that it's critical for it to address these specific features of Git, that being branch awareness, cross-platform support, both on the server and on the back end, or on the server back end and in the local machine, and also performance, which is to say that if we have to do a large number of serial operations, which is a common co-occurrence with large files, that we need to be able to cycle through those files very quickly and get to a result very quickly as well. Thank you for your time. Please speak with me or Nicola or Steve afterwards, and let us know if you have any comments or suggestions.
Sir?
Thank you.